the ISO OSI reference model and the IEEE standards. The next slide will be discussing the objectives of this presentation. We will be discussing today the most popular ISO OSI 7-layer communication reference model. We will also be explaining the reference model and standards which are relevant to network communication. Also, the presentation describes the different IEEE standards that apply to different types of the network. Module 1 of this presentation refers to the overview of ISO and its 7-layer OSI model. The models and standards in communication. In communication, we have established standards, and these standards are known as the protocols. For implementation, a framework is helpful in the design of hardware and software for communication. ISO OSI reference model serves this purpose. ISO also supersedes the TCP/IP model to the Transmission Control Protocol Internet Protocol model. ISO stands for International Standards Organization and OSI stands for Open Systems Interconnect. The background of OSI model. It was introduced in 1978 and then was revised in 1984. It formulates the communication process into structured layers. That is why it is known as the layered model. There are 7 layers in the model and hence the name 7-layer model. The model acts as a frame of reference in the design of communications and networking products. This slide shows a layered approach to communication. We will start with the physical layer, then move on to the data link layer, corresponded by network, transport, session, presentation, and lastly, the application layer. We will be discussing the function of all of these in the coming slides. The division of the layers. We divide these 7 layers into lower, middle, and upper layers as shown in the presentation. The physical and the data link layers belong to the lower layers, network transport layers belong to the middle layer, and the rest of the layers, that is session, presentation, and application, correspond to the upper layers. The function of a layer. As can be seen in the slide, each layer deals with one aspect of networking. Layer 1 in the OSI model deals with the communication medium. Each layer communicates with adjacent layers in both the directions. Example, network layer communicates with transport layer and the data link layer. Each layer formats the data packet. Example, it would either delete or add the addresses. This slide shows the role of layers, the node A and node B. So what we are doing is, from node A, the data will be going from the application layer, then to the presentation layer, and it will pass through the rest of the layers, reaching the physical layer, from where the data will go out to node B. Similarly, if we have any data coming from node B, it will be coming in, that is data in arrow that shows, it will be going into the physical layer and then it will reach to application layer and hence the node A. The communication between the layers. The communication between the layers is as shown in the slide. Data encapsulation and data stripping are the two processes that take place between the application and presentation layer and the presentation and session layer respectively. The role of layers is point-to-point communication. Point-to-point communication refers to the communication taking place between two nodes. Here in the slide we have shown node A and node B. The application layer takes the data to the physical layer from node A, and similarly the node B, which is present at the application layer, will be transferring the data to the physical layer, and through the physical layers of both these nodes the communication will happen through data exchange. The virtual communication between layers. The slide shows how the virtual communication between the layers takes place between two nodes. Here ends our module 1, which had shown all the objectives that we had done, that the role of the physical layers, all the layers of OSI model, etc. Next, the module 2 would be covering up the ISO upper layers. That is, the module objectives of this slide would be network layer, transport layer, session, presentation, and application layer functions. First of all, we will discuss the user layer, that is the application layer. The purpose of this layer is to user application to network service interface. Examples of this layer are file request from the server, email services, etc. network access, flow control, and error recovery. Next, we move on to the presentation layer. The purpose of this layer is to format data for exchange between points of communication, for example, between nodes within a network. Here we give an example for this: redirector software. It formats for transmission to the server. The functions of the presentation layers are protocol conversion, data translation, encryption, character set conversion, expansion of graphics command, etc. Here we are giving the redirector example in which you can see the redirector between the server and the local disk and how the communication takes place here. Next we move on to the session layer. The purpose of the session layer is to oversee a communication session, that is session building, and the steps involved in this are establish, maintain, terminate. That is, first of all we will be establishing the connection or session between two nodes. Next step would be to maintain it as long as the data exchange is to be there, and finally we have to terminate the session as soon as the data transmission is over. The session layer functions are: it performs name recognition and related security. It also is responsible for synchronization between the sender and the receiver. Also, the assignment of time for transmission, that is, it will assign the start time and the end time, etc. The purpose of the transport layer, which is the fourth layer, is the repackaging proper and efficient delivery of the packages. It relieves error-free, in sequence, and without duplication repackaging. So next we move on to the functions of the transport layer. It is used for sending the data, as we discussed in the previous slide. It will be used for repackaging the message to fit into the packets. It sends long messages first of all, and it will then assemble the small messages. Then its function on receiving the data is to perform the reverse, that is, it will have to assemble the small messages and make them into a very long message that the original message was. It then sends an acknowledgement to the sender on the reception of the data. It also performs this function of solving packet problems, which occurs during the transmission and the reception of data. So the transport layer performs very important functions in the OSI model. Next layer is the network layer. The purpose of the network layer, as can be seen in this slide, is addressing and routing of the packets. That is, the data, how it will travel, and the routing of the data within the layer. The example application at the router. If the packet is very large, it will be split into very small packets so as the routing becomes easy. The functions of the network layers are address messages, address translation from logical to physical. For example, this example has been given in which the logical is converted to the physical address. Then the routing of the data, which would be based on priority. Priority would be the data that comes in first will go out first. The best path at the time of transmission, that is the shortest path or the most reliable path. Congestion control. Here ends the module 2, in which we have studied all the upper layers of OSI reference module. Next we move to the other module, which covers the OSI lower layers. OSI lower layers, as we had seen in the diagram, were data link layer and the physical layer. So the purpose of the data link layer is to manage the flow of data. As the name suggests, data link. It manages the flow of data over the physical media. Also, it is responsible for error-free transmission over the physical media. It also assures error-free data submission to the network layer. Data link layer function. It describes the point of origin, packages data for transmission over physical line. At the receiving end, it packages data for submission to the network layer. It also deals with network transmission protocols. For example, the IEEE 802 protocol. The data link layer is subdivided into two layers. As we see here, these are known as the sub-layers. It is done to improve the OSI model. One of the layers is the logical link control layer, which was also known as the LSC, which manages the service access points. And the other function of LSC is error and flow control. Next layer is the media access control, MAC sub-layer. It applies directly to network card communication, and it also performs the function of access control. Here we card driver, the NIC driver which facilitates the data transfer. Here we have the network software and the network card. Next we see the function of the physical layer. The purpose of the physical layer is that it deals with the transmission of OS and 1S over the physical media.